Okay, let's start. Last class, we check. So we did this exercise to in-class exercise to see if R is in second normal form or not. So we just follow the same way as what we did in the example. So already know the keys, and we just need to first find out the non-prime attributes. Okay, and so for non-prime attribute, I know A is a part of a key, B is part of a key, so A, B, they are prime, and C is non-prime, D is also non-prime. And then I want to see first non-prime is a C fully functional dependent on this key or not. We only have one key, so so I'm going to write down maybe here. So is C. Right, so have this question, and we can see the only functional dependent related to ABC is FD1. So FD2 doesn't help anything on this question. So the answer is yes. So in other words, AB is the left-hand set. You cannot remove anything from the left-hand set. Okay, and the second, we do the same thing for D. So we want to see if D is fully okay, and so in this one, we have two functional dependency from AB to D and from A to D, right? And so from that, we can see we do not need a B. The B here is the one that not required to be on the left. So A to D is true already. So we can see this particular one, that's actually this, right? This is not a full functional dependency. This is a partial. So the answer to this question is no, right? So as a result, your final answer, right? So your answer is no, R is not in second normal form, right? So the reason is, what is the reason? Reason is non-prime attribute. Well, let me write it down. Maybe I'll just put on here. So have a little bit space here. So the reason is non-prime attribute is all right. Okay, so this is another example of no, right? So we have this is no, and this exercise is also no. And let's see something different. Let's do another in-class exercise. Our relation R has A, B, C, D, E. And I have two keys, A, B, and so A, B combination is a key. Okay, actually, let me make it consistent. A, B, right? And another key is C and D. Okay, and let me give you a functional dependency. Let me do this way. So it's A, B to C, D, E. Another one is B, C, so C, D. Right, so two functional dependency. This is FD1, FD2. Okay, and my question is R in second normal form and Y? Okay, I give you 4 minutes on this. So work on this and then we'll talk about the correct way to answer this. Okay, so let's take a look about this. And always our first step to get an M prime. In this case, we only have one M prime because AB is here, right? CD is here, so only one M prime is E. Okay, and so we need to check. First of all, I need to check is E I want to see if E is fully functionally dependent on AB. In other words, I want to see if AB to E is the full functional dependency or not, right? So we can see, so from AB to E, right? So this AB to CDE means AB to E is true. Remember the decomposition rule. And I cannot remove B, I cannot remove A from the given functional dependency and from the inference rules. So that's why this is yes. Okay, and the second one, okay, let me write it the other way. The other way is I want to see from CD to E, right? E is non-prime, this is a key. Is this one full functional dependency? Right, so I want to see if this is full or not, and the answer is yes. Because from what we have here, you don't see anything that can tell you to remove D or remove C to produce E. So that's why this is also yes. Okay, and so this one actually show you the yes case. I have one non-prime fully dependent on the first key and fully dependent on the second key, right? So as a result, so your final answer can be, so our final answer is yes, R is in second normal form. And of course, the reason is here, right? The one above it is the reason. So in other words, when I do grading, I'll read from the beginning, then I can see you reach this point. And because each of them no relation, so that's why this is yes. Okay. That's for second normal form. And this is the hardest one to work on. Then when we move on to the next one, the third, and voice code normal form, actually they are relatively easy. So we actually now ready to move on. Okay, so let's see the third normal form. So let's see the definition for the trivial functional dependency. That's something means if Y is a subset of X, and then this is a trivial functional dependency, otherwise it's non-trivial. The reason we define this is because if Y is a subset of X, this is always true, right? So for example, if you say SSN ename to ename, and this is always true. So that's why I don't want to check things like this, right? I don't want to consider this one to do the following third normal form checking. So I only want to consider non-trivial functional dependency. So this is case, this is a trivial case. All right, so now let's see the definition of a third normal form. And one more time, in order to get points in the exam, you must follow this definition for third normal form. Okay, and if you use any other way to check third normal form, even if it is correct, you get 0 for it. And you have to use this definition. Okay. So whenever there's a non-trivial functional dependency x to a, then, okay, so any x to a, okay, so again, we don't want to consider this case, right? So for x to a, we have two conditions. Left-hand set is a super key. And what's the super key? We covered that in the previous class. Super key is a unique identifier, right? So everything else functionally depends on super key. So X is a super key, right? Or A is a prime attribute. So we just finished the prime, when we do the second normal form, you know what is a prime. So two condition is very important. This is or. So if the first one is true, you do not need to check the second one just because this is or. You can check this first or you can check this first. Doesn't matter, which one you want to work on first, but this is or one of them satisfied. Then we have that particular non-trivial functional dependence satisfied. You should move on to the next one, and every single one should be no relation. Then you can say third normal form. But if you found the one relation, then we can say no, it's not in third normal form. Okay. Okay, so let's try to, so this is basically depends on your understanding of the super key and the prime, right? Okay, so let's, actually I want to show you one thing. So let's using this example here. And in this example, I'm going to give you two keys. That's one key and the combination is the second key. And then I have the following functional dependency here. And my question is this a third normal form or not, and why? And let's check this. And before we do this, I'm going to show you one trick. Can save you a lot of effort. Okay, so remember we need to check a super key, right? So one way to check a super key is we know any key is a super key, right? We know this is true because key is a super key with additional restriction. That means key must be minimum, right? So any key is a super key. So if the key is given, right? So what is a super key? Super key should be, so this part is the key, for example. And super key can be exactly the same thing. So if you say this particular one is a super key or not, yes, because of that, right? Or if you have something else, so I have another attributes like X here, this whole thing is also super key. So this part can be nothing. And so the key itself is super key, or it can be key and something else, because super key doesn't require to be minimal, but this must be unique identifier. So in the example I gave to you, since I give you the keys already, so you know this particular one, right? The one I gave to you, this is a super key. You also know this is a super key. So that makes things easier. Okay. All right, and so now let's see this one. And so in order to check a third normal form, and remember we need to follow the definition. So for every single functional dependency, I need to check condition 1 or condition 2. So all the functional dependency I give here is non-trivial, so that's why I need to check every single one. So for the first functional dependency, right down here. So first functional dependency FD1 here, and I want to see the left-hand side is a super key or not, right? Two conditions. So let's take a look about this one more time. So two conditions. So this is the left-hand side. I want to see if this one is a super key or not. Yes or no? Yes, right? So this is a super key. Remember, I just showed you any key is a super key. So this is already given to say this is a key. So that's why this is a super key. And since this is true, we do not need to check the second condition, not at all, right? So this is good enough. So this one tell you FD1 normalization. Right? Okay, so let's move on to FD2. That's the left-hand side. Okay, so this one, we want to see left-hand side is a super key or not. It is okay to check the second condition firstly. Okay, nothing wrong, you check this firstly. So this one, since this is a given here, any key is a super key, so this is the super key. And this one tell you FD2 normalization. Number 3. So let's see the last one. And left-hand side, this one is this a super key or not? This is not a super key. So we want to see something is super key or not. It must contain the key, right? So I remember I just erased that. It must be a key and something else. This something else can be nothing. So this one doesn't have any component of the given key. So that's why this is not a super key. Another way to do is you can calculate the closure of this. And according to the closure definition, this one only has 2 elements, right? And this one doesn't include all the attributes. So that's why this is not a super key. So either way, whichever way you'll be able to tell, you don't need to show this to me, okay? You only need to give me the conclusion, this is not a super key, or this is a super key like this. So we know this is not a super key. So in this case, I have to check the second condition, right? So we want to see price. Is the price a prime attribute or not? So I want to see if it's a prime or not. And we can see price is not a prime attribute. So we know prime attribute must be part of key, right? Price is not part of this key. Price is not part of this key. So that's why it's not a prime attribute. So here we found the relation, right? Okay, so what is the final answer? Your final answer. So no, and this is a relation name. It's not in Solomon form. And you don't need to repeat this if you write down this way, because I can see clearly you show me the relation here. Okay, another way. So you can also, after you finish this, well, where can I put it in? Okay, let me put this here. So after you finish this, you can also write a reason explicitly. If you want to do one actual step, you can see FD4 is the relation. After you finish this, you can write this down. Basically, I want to see this one. Yeah, you may also, for example, highlight this like that. Or, but anyway, as long as you write down, I'll be able to see it. So it'll be nice if you put down one actual step, but not required. But you have to write down relation here. Otherwise, it's not a obvious stat. Why this is not? Because you found one relation. So this is actually a similar case. If you handle FD4 first, then you immediately found the relation. And that's good enough. So say you start with FD4, you found out relation, your answer is no. And that's 100%, right? Okay, but similar to second normal form, say you did this step correctly, but you made a mistake in this step, you still can get partial credit on that one. So basically, I want to see if you know something, how to apply things correctly in order to give you partial credit. But to be honest, most of people, they be able to figure out this, most likely they be able to figure out other things also. Yeah. So if you know how to apply to one functional dependency, usually people know how to apply to others because they have the same logic. Okay. Okay, so that's third normal form. And we'll do one thing is I'm going to give you an in-class exercise. So you'll be able to know if you understand everything about third normal form or not before we move on. So we are going to use this slide, but I'm going to modify this. So not BCNF, okay? So this is actually an in-class exercise. And I'm going to give you two keys, right? You see two keys, and that's the functional dependencies. And I want to ask you, is this a third normal form or not, and why? Okay, I give you, let's see, 3 minutes on this. Okay, so let's see, for this case, this is actually quite similar, right? So let's see the first functional dependency, FD1. And we can see the left-hand side is a property ID. And we can see property ID is the given key. So this is a super key. Okay, so the first one, no relation. And now let's see FD2. And that's coming from counting name lots number together on the left-hand side. And we can see so this is a super key. So this also no relation, right? We don't even need to check the second condition. And let me get rid of this so I have more space. Okay, so let's see the last one, FD5. Okay, and this left-hand set is not a super key. So we know that because this is the one, this one does not contain the keys, right? Also, when we calculate the closure of this, I only have 2 attributes instead of 4, so that's why this is not a super key. Then we check the second condition, and that's the right-hand set. And in this case, the right-hand set is county name. So county name is a prime attribute or not. County name is a part of the second key, right? It's part of this key. So this is a prime attribute. So you can see, although this is not true, but this is true. And third normal form only require one of them to be true. So that's why here, normalization. So as a result, your answer should be is in third normal form. So this is actually a yes case, right? Okay, so in the case of yes, every single step has the certain points. So for example, if you get this part done, but this is missing or wrong, or this is missing or wrong, then you only have part of the score. You don't get 100%. I only can give you the score related to that, not the FD1 and 2. That's actually kind of common. People just put on 1 and forgot the rest. Remember, in order to be third normal form, when we go to definition, every single functional dependency must be checked to make sure no violation. Okay, so this is a case to show you another third normal form, right? And we're going to go back to this using the same example to show Boyce code normal form. So far we finished the first, second, and third. Let's move on to Boyce code normal form. So Boyce code normal form has most strict definition. It said whenever a non-trivial functional dependency x to a, then the left-hand set x must be a super key. That's all. Okay, only one condition, super easy to do, right? Compared to the second normal form and third normal form, really easy to do. Left-hand set, super key. So in other words, we have the case that the right-hand side is a prime. We don't count them in BCNF. And so the rule is every second is in first, every third in second, every BCNF is in third normal form. This is the one more easy to see because third normal form, there's all, right? 2 conditions. This is only 1 condition. So each normal form we learn is strictly stronger than the previous one. They have more regulations. Although in the definition, you don't see it directly, but they are more strict. So to show BCF is more strict than third, I can show you an example that is in third normal form, but not in BCF. Right, so that means which is most strong? BCF, right? It's the most strict. So this is actually a good example, right? So this one we already work on this, and I know this is in BCF, right? I mean, sorry, in third normal form, right? In third normal form. And now I want to see if this is in BCF or not. Okay, so let me get rid of that. Remember, it is in third normal form already. We'll check. Okay, so now let's see, same question, right? And now we only have 1 condition to verify. So for the first functional dependence FD1 here, we know the left-hand set. So now you only care about left-hand set. Okay, right-hand set, we don't need to consider. So for FD1, property ID, right? This is the left-hand set. This is a super key. The reason is, as I talked already, this is given. Okay, the second one is FD2. So content name, lots number together, and that's actually this, right? So that's why this the left-hand set. So this is a super key. Okay, the third one. Okay, so you can say maybe here, no relation. And this is no relation. And so the last one, the left-hand set. Okay. Left-hand set, we already know this is not the super key. And we know it's not a super key, right? So that's why this is relation. So as a result, that is, this one is not in BCNF, right? And you also can say FD5 or is PCNF, right? Okay, and also, so this is BCNF. Once you know how to do third normal form, the BCNF, checking BCNF is really straightforward, right? But this example actually show you this is not in BCNF, but it's in third normal form. So at least this one show you this is most strict. And of course, we know most strict because this one allow two condition, 1 or 2, and this one only allow one condition, 1, right? Okay, so let's do another important exercise for BCNF and to make sure you understand everything. Okay, so I have R and give you A, B, C, D, E. So two functional dependencies. Make you the key first. That's A and B. Okay, the question. Okay, so you can do this. I mean, this in class exercise, finish this, and we'll cover. So, hold on. And we'll let me get rid of this. Okay, so so we're going to talk about the solution next class.